Hello everyone, welcome to the second lab section for IE 467. In this section, we will learn two cases. One is the specialized serial processing, and another is the generalized parallel processing. A classic operational question is whether to have specialized or generalized workers when processing involves multiple different tasks. A related question is how processing time variability affects the decision. Arguments can be made for both specialized and generalized work, depending on the setting, and experiments have been conducted on real systems, sometimes with disappointing results. A careful simulation study might help avoid such disappointments. Let's consider a loan application office, where applications arrive with exponentially distributed inter-arrival times with mean 1.25 hours. The first application arrives at time 0. Processing each application requires 4 steps. First, a credit check, then preparing the loan covenant, then pricing the loan, and finally disbursement of funds. For each application, the steps have to be independent of the other steps and of the arrival process. Initially, the system is empty and idle, and we will ride for 160 hours. Output performance measures includes the average and maximum total time of applications in process, and the average and maximum total time from entry to exit that the applications spend in the system, as well as their time waiting for the next processing step to begin. Let's first study specialized separate work. For the specialized separate work, the first thought might to be specialize the employees and assign, say, Alfie to check credit for all applications, Betty to prepare all covenants, Chuck to press all loans, and Doris to disburse all funds. So each application would first have to go through Alfie, then Betty, then Chuck, and finally Doris. So how to use Arena software to simulate this process? Let's first open the Arena software. As I mentioned before, the simulation always starts at the create module, so we drag the create module into the model window. Then double-click the create module. First, we change the create module name to the application arrives. Then change the entity name to the application. Because we know that the applications arrive with exponentially distributed inter-arrival times with mean 1.25 hours, so that we set the type as a random expo. The value change 1 to 1.25, and the unit is hours. Finally, we click OK button. Next, we have to make sure that the entity name here should match the create module's entity name. Next, we drag the process module into the model window. Then click the Connect button to connect the create module with the process module. Then double-click the process module. First, we change the name to the Alfie checks credit. Then set the action as a seize, delete, and release. Later, add the resource. We change the name to the Alfie, and select OK. For the delay type, we know that for each step, the time is exponentially distributed within 1 hour, so that the delay type is expression. The unit is hours, and then we use the build expression and then go to the random distribution, find the exponential, and the mean is 1, and select OK. Here. And we can tune the Q position like here. Let's go to the entity data module again. In this example, the default entity pictures is a picture point report, which is OK, so that we don't need to change the entity appearance. The only appearance we need to change is for the resource, so that we can go to the animate toolbar, then click the resource button, and tap the resource name alpha. We assume this process will never fail and will never inactive. And we use the green circle to represent the idle, and the blue circle to represent the busy. Please always remember to click the seize area. Then click OK. Now, the Arena software asks us to decide the source position and choose it here. Let's move to the second process. So we first drag the process module into the model window again. Then click the Connect button to connect the first process with the second process. Next, double-click the process module. In this dialog, we first change the process name to the Betty Prepares Covenant. Then set the action as the seize, delete, and release. Next, as the resource, we change the resource name to the Betty. And click OK. For the delete tab, we choose use expression. The unit keep as the hours. And we use the build expression button to find the random distribution. Then choose the exponential and set the mean value as 1. Okay. Tune the Q position like this way, and add the resource animation. Click the resource button and change the resource name to the Betty, and delay the field inactive, and use the green color to represent idle, and the blue color to represent busy, and select this area. Set OK. Then choose the position here. Let's do the same thing for the third process. So we drag the process module into the model window. Then add the connection. And double-click the process module. In this dialog, we change the name to the check. Prices loan. And set the action at the seize, delay, and release. Add the resource. Change the resource name to the check. And click OK. And for the delay tab, we choose expression and use the build expression button to find a random distribution. And finally, choose exponential, and we set the mean value as 1. And click OK. And OK. Then we tune the Q position. Finally, add the animation for resource. And change the name to check. And delay the field inactive, and use the green circle to represent idle, the blue circle to represent the busy, and click the seize area. Then find a position here. So we do the same thing for the last process. Drag the process module and change the process name to the doors disperse funds. And the action set as a easily release, and add the resource and change the resource name to the doors. And the delay tab, change it to the expression, and find the exponential distribution, and the mean value, change it to 1. Set OK. OK. And add the connection, tune the Q position, and add the resource animation. Delay the field inactive, and use the green circle to represent idle, and the blue circle to represent busy, and select this area. Finally, drag the dispose module into the model window to end this flow chart. We first add the connection. Then change the dispose name to the application depart. Now the flowchart is ready. Let's do one more thing. Let's draw the dynamic plot. To draw the dynamic plot, we should go to the Anime toolbar, then click the chart button to find the plot. We first add the series, and then we click this button and choose build expression, and we go to the entity and choose the number in process and click OK. And we'll change the name to the number in process. And because we don't want the legend, we will not like it show. And for the axis, we'll go to let it is visible and change the name to the time hour. And select the maximum value and change the value to the 160. Okay. And we choose the y-axis and let it is visible. And change the number in process. And click OK. Now we have to decide its location. Put it here. Okay, everything is done. To run this simulation, we need to set some running conditions. So that we go to a run toolbar, then click the setup button. And first we set the project parameters, then change the project title to the loan application. Next, go to the replication parameters. Change the length to 160. Make sure that the time unit is hour. Let's go to the project parameters again. Please make sure that the process, this one, has been selected. Finally, we click OK, then run this simulation. Okay, let's click yes to see the result. This is how report looks like. From the report, we can know that the average total time is 16 hours, and the maximum total time is 27 hours. Note that this counts only those applications that had left the system when the simulation stopped, not those that were still in process at that time. And the average waiting time is around 12 hours, and the maximum waiting time is around 22 hours. Then go to this table. We know that during the 160 hours, 101 and 70 applications were completed. And we can also know that in the first process, 82% of time is busy, and in the second process, 70% of time is busy, and in the third process, 80% of time is busy, and for the last process, 80% of time is busy. Let's move to another cases. Think about this question. Would it be better to generalize the work so that each employee completely processes all 4 steps of one application at a time and with a single queue of applications feeding the group? These pictures show how this works, where each employee processes all 4 steps before moving on to the next application in queue. Let's do it together to simulate this process. Firstly, we drag the create module into the model window, then change the name to the application arrays. Then change the entity name to the application. And set value to the 1.25 and keep the hour as the units. Then click OK. Next, drag the process module into the model window. Double-click the process module. First, we change the name to the one of the people processes all 4 steps. And choose the cease delay release. Add the resource. You can change the resource name to the loan officer. And keep 1 as a unit to see the release. This 1 represents the number of units of the loan officer resource that are seized and released by each application entity. And click OK. And for the delay type, we know its expression. And for each employee must complete all 4 steps before taking the next application out of queue. And for each step which requires as per 1 hour to complete, so that we can simplify tab as per 1 plus x per 1 plus x per 1 plus x per 1. And you can also type 4 multiply x per 1. And click OK. And then tune the queue position. Let's add the resource animation. We type the resource name, loan officer, and we all assume this process will never fail and will never inactive. And we do the same thing again. We use the green circle to represent idle and the blue circle to represent busy. Then we double click the idle button And first we select this green color, then duplicate it 3 times and line them all up vertically. Now the software asks us to decide the location here. Then choose these 2 circles, copy and paste here. Next, we close this screen and do the same things for the busy bar. First, select it, copy and paste. Then choose these 2 blue circle, copy, paste, and close this screen. And please select this area and select OK. Now this arena let us to decide the resource animation location. You can put it here and change the location to this way. Now, in this animation, it only has one sys area, but there exists 4 processes. So that we have to duplicate this sys area 3 times. So we double click the sys area and choose the point button, then add 3 points. And we can also click the use defined, and we can use this to change its angle. But in this example, we will keep it as 1. Then click OK and choose OK. Now you can see there has 4 sys area, so we can drag them to each circle. Because we have 4 employees, so that we have to go to the data decision bar and choose the resource data module. And for the capacity, we change 1 to 4. Okay. Finally, we drag the dispose module into the model window, then add the connection, change the name to the application departs. Click OK. Before run this simulation, we have set some conditions. So we go to the run bar and set a setup. And in the project parameter, we change the name to the loan application 2. And please make sure that the process has been selected. And in the replication parameters, we change the replication length to the 160. We should make sure that the time unit is hour. Then click OK. Let's run this simulation. Okay, let's run this simulation. Now the report is ready. Let's click yes to see the result. This is how report looks like. let's see that the average waiting time is around 1.32 hours, and the maximum value is about 6.8 hours. And the total time, the average value is 5 hours, and the maximum value is about 13 hours. Compared with the previous cases, this value is much smaller. Then go to this table, and we can find that during 160 hours, there has 165 applications was complete.